Welcome to Understand the Math. In this video, we're going to learn about hyperbolas, what they look like, what their key components are, and how to write equations that describe them. We'll start with an example that shows how to find the vertices, foci, asymptotes, and transverse axis length of a hyperbola and then sketch its graph. Then we'll look at examples where we're given specific information such as the foci and vertices, vertices and asymptotes, or vertices and a point, and use that to find the equation of the hyperbola. Let's get started. We'll begin with some Hyperbola Essentials, what they look like and the types of equations that describe them. A hyperbola has two vertices, here and here. They're points where the graph changes direction. The vertices lie on the transverse axis, one on each side of the center. They mark the closest points of the two branches of the hyperbola to the center. The transverse axis right here is just the line segment that connects the two vertices. It lies along the direction in which the hyperbola opens. In this graph, the hyperbola opens left and right, but you could also have one that opens up and down. A hyperbola also has two foci. We call them focus if it's singular, foci if it's plural, and they're just the points that each branch of the hyperbola bends around. They lie inside each branch and they lie along the transverse axis, but they are farther from the center than the vertices are. Let's now look at how we define a hyperbola. A hyperbola is the set of all points, such as this point here, or the vertices, such that the difference of the distances from any fixed point on the hyperbola to two fixed points called the foci, that's this distance here and this distance here, is constant. The difference between those two distances is a constant. In the graph here on the left, the hyperbola opens to the right and to the left, and it's described down here at the bottom by this equation. The x squared term has a plus in front of it, and then the y squared term has a negative in front of it, and a squared, which relates to the vertices, is under the x squared term. The transverse axis is horizontal, and the asymptotes are given by y is equal to b divided by a times x, or minus b divided by a times x. One way that you can remember this is that plus or minus b divided by a is the slope, and the slope is the change in y over the change in x, and the b squared term is under the y squared, and the x squared is under the a squared. Let's now look at the graph on the right. This hyperbola opens upward and downward, and its equation is equal to y squared divided by a squared minus x squared divided by b squared. Here, the y squared has a plus in front of it, and the x squared has a minus in front of it. And then the a squared is under the y squared term. The transverse axis is vertical, and then the asymptotes are given by y is equal to a divided by b times x, or minus a divided by b times x. Plus or minus a over b is the slope, change in y over change in x, and notice that the a squared is under the y squared, and the b squared is under the x squared. Notice also that in each graph, there are two foci, here and here, and then here and here. And you can find where they're located by using the equation c squared is equal to a squared plus b squared. We're now going to look at an example where we are going to find the vertices, foci, asymptotes, transverse axis length, and then sketch the graph. In part A, the equation that we're given is x squared divided by 4 minus y squared divided by 16 is equal to 1. Let's begin by writing down the general form of the equation. That general form is x squared divided by a squared minus y squared divided by b squared is equal to 1. Because the x squared term has a plus in front of it, the hyperbola has a horizontal transverse axis. This just means that the parabola is going to open to the right and to the left. Let's start by finding the vertices. The vertices, by definition, are equal to a, 0 and minus a, 0. So we need to start by finding what a is. To find a, all we have to do is compare this a squared with this number. So we have a squared is equal to 4, which means that a is equal to 2. So we know that our vertices are going to be 2, 0 and minus 2, 0. Now let's find our foci. Our foci are given by the coordinates c, 0 and minus c, 0. To find c, we are going to use the equation that c squared is equal to a squared plus b squared. We know a squared, and now we need to find b squared. We can find it by just going back up and looking at our equations. Here's our b squared, and it's going to be equal to 16. Let's go ahead and let's write that down. B squared is equal to 16. When we find our asymptotes, we're going to need to know b, so let's just go ahead and write down that b is equal to 4. Now we can plug in and find c squared. C squared is equal to a squared, which is 4, plus b squared, which is 16. So our c squared is equal to 20, and that tells us that our c is the square root of 20. When we go to graph our hyperbola, we are going to need to know what the square root of 20 is, so I'm going to go ahead and write it down now. If you put this into your calculator, you'll find that the square root of 20 is approximately 4.5. Now let's go ahead and write down what our foci are. They are c, which is the square root of 20, 0, and minus square root of 20, 0. Let's now look at our asymptotes. Our asymptotes are given by the equation y is equal to plus or minus b divided by a times x. Let's go ahead and plug in what that is. Our b is 4 and our a is 2. So we have plus or minus 4 divided by 2x, which tells us that our asymptotes are y is equal to 2x and y is equal to minus 2x. The last thing we need to find is our transverse axis length. And it is equal to 2a. So this is just 2 times a, which is 2, which is equal to 4. Now we can go ahead and sketch the graph. To make things easier, I've written down some steps that we can follow. The first step is to sketch what we call the central box. Let's go back for a minute and look at our graph on the previous page. The central box is that box that is written in red. Because our hyperbola opens to the right and left, to sketch our central box, we're going to march out a units to the right and to the left, and we found up above that a was equal to 2. So we're going to come out 2 units here and 2 units here. And then we're going to march up and down b units, and b is equal to 4. So here's going up 4 units and going down 4 units. Now we can go ahead and just graph our box. And there it is. The next thing that we want to do is sketch the asymptotes. This is actually really easy to do now that we have our boxes in place. The asymptotes are just going to connect the corners of the boxes. Our first asymptote's going to look like this, and then our next asymptote looks like this. Let's go ahead and label these asymptotes. The one on the right is y is equal to 2x, and the one on the left is y is equal to minus 2x. Let's now look at our third step. We are going to plot the vertices and the foci. Because our hyperbola is going to open to the right and to the left, our vertices are going to be located here and here. They always go on the box that you draw. And then the foci are going to be to the right and left of the vertices. We found that C was equal to the square root of 20, which was approximately 4.5. So we're going to march out 4.5 to the right and 4.5 to the left. So those are our foci. Now we can go ahead and sketch the hyperbola and label the points. To sketch the hyperbola, I'm going to start on the right, and what you're going to do is you're going to kind of follow this box and then follow the asymptote to make it look like that. So you're going to follow the box and then the asymptote, and then follow the box and then the asymptote. Now the last thing that we're going to do is label our points. Our vertices were located at 2, 0 and minus 2, 0. And then our foci were located at square root of 20, comma 0, and then minus square root of 20, comma 0. And that's it. Let's do another one just like this, but instead of opening right and left, it's going to open up and down. The example that we're now going to look at is the hyperbola y squared over 9 minus x squared over 25 is equal to 1. We're going to find the vertices, foci, asymptotes, transverse axis length, and then we're going to sketch the graph. Let's again start by writing down the general form of the equation. That's y squared over a squared minus x squared over b squared is equal to 1. Because the y squared has the plus in front of it, the hyperbola is going to have a vertical transverse axis. That just means it's going to open up and it's going to open down. Let's start by finding the vertices. Because it opens up and down, the vertices are going to be given by 0, comma a, and 0, comma minus a. A squared is equal to 9, which means that a is equal to 3. So we can write down that our vertices are 0, comma 3 and 0, comma minus 3. Let's now find the foci. They are given by 0, comma c and 0, comma minus c, where c squared is equal to a squared plus b squared. We saw that our a squared is equal to 9. And now if we look back up at our equations, our b squared is equal to 25. So we're going to add 25 and we get 34. So this tells us that c is the square root of 34. When we go to graph the foci, we need to know what the square root of 34 is. So let's just write down that the square root of 34 is approximately 5.8. You can just plug that into your calculator to find that. Now let's write down what our foci are. They are equal to 0, comma square root of 34 and 0, comma minus the square root of 34. Now let's find our asymptotes. Because the a squared is under the y squared, our asymptotes are given by y is equal to plus or minus a over b times x. Our a we found was 3, so this is plus or minus 3 divided by our b, and I actually don't think we found our b. So let's go ahead and let's do that. Let me go over here to the left. We found that b squared was 25, so our b is just equal to 5. So we can come down here and plug this in. So we have plus or minus 3 divided by 5 times x. So we can write down that our asymptotes are 3 divided by 5x and minus 3 divided by 5 times x. Before we go to our graph, we still need to find one more thing, and it's the transverse axis length. So let's say the transverse axis length. That is given by the formula 2a. And we know that a is 3, so this is just 2 times 3, and it's equal to 6. Remember that the transverse axis is just the piece of the graph that lies between the vertices. Let's go ahead and sketch our graph. We have the same steps that we did before. We're going to start by sketching the central box. Our hyperbola is going to open up and down, so we're going to begin by marching up a units, and a was equal to 3. So we're going to march up 3 units and down 3 units. And then to the right, we're going to march out b units, and b was equal to 5. So let's see, 1, 2, 3, 4. Here's 5. And then to the left, 1, 2, 3, 4, 5. And there's 5. Now we can go ahead and just draw our box. And there's our box. The next thing that we're going to do is sketch the asymptotes. Remember, they are just the lines that are going to go through the corners of the boxes. So starting in the lower left, I'm going to draw our line, try to be really neat about it. There's our first one. And then here is our second one. The next thing that we're going to do is plot the vertices. Our parabola opens up and down, so our vertices are going to lie along the y-axis, and they're going to be located here and then down here. Now let's go ahead and put the foci. They are at 0c and 0 minus c, and then c was 5.8. So let's march up 3, 4, 5, 5.8, and march down 5.8. So 1, 2, 3, 4, 5.8. Now we can go ahead and sketch the hyperbola. I'm going to sketch the upper piece first. We're going to follow the box and then follow the asymptote. We're going to follow the box again and then the asymptote. And then the same thing for the bottom part of the hyperbola. We're going to follow the box and then the asymptote and then the box and the asymptote. Now, the only thing we have left to do is to label everything. Our vertices are located at 0, 3 and 0, minus 3. Our foci are located at 0, square root 34, up at the top, and then down here at the bottom, 0 minus square root 34. And then let's label our asymptotes. This one is y is equal to 3 divided by 5 times x. And then on the left, we have y is equal to minus 3 divided by 5 times x. And that's it. Let's now look at some examples that are more algebraic. We are going to look at 3 examples where we're given some information that will enable us to find the equation of a hyperbola. In our first example, we are given the foci and vertices. The foci are equal to plus or minus 5, 0, and the vertices are equal to plus or minus 3, 0. Notice that the x component of the foci and the vertices changes, so that means we are going to have a horizontal transverse axis, and our equation is going to be x squared divided by a squared minus y squared divided by b squared is equal to 1. Now we just have to find a squared and b squared. We can find a squared from the vertices. Since our vertices are plus or minus 3, 0, we know that a is equal to 3, so a squared is equal to 9. Now to find b, we have to use the other piece of information that we're given, which is our foci, and this tells us that c is equal to 5. So in order to find b squared, we need to use the formula that c squared is equal to a squared plus b squared. Let's go ahead and let's plug in for c and a. C is 5, so 5 squared. And then we already figured out what a squared is. That's 9 plus b squared. So this is 25 minus 9 is b squared, which gives us, let's see, 25 minus 9 is 16. So b squared is 16. Now we can just write down the equation. It's x squared divided by a squared, which is 9, minus y squared divided by b squared, which is 16, is equal to 1. Let's now look at example 3. In this example, we are given vertices and asymptotes. The vertices are 0, plus or minus 6, and the asymptotes are y is equal to plus or minus 2 times x. Let's begin by writing down our equation. Notice that the y component of the vertices changes, so that means our equation is given by y squared over a squared minus x squared over b squared is equal to 1. Our vertices tell us that a is equal to 6, so a squared is 36, and then we're going to have to find b from our asymptotes. The equation for our asymptotes are given by y is equal to plus or minus a divided by b times x. That's because the a squared is under the y squared, that the a is on top. And this is equal to what we were given, plus or minus 2x. So all we have to do is equate a over b with 2. Let's go ahead and let's write that down. A divided by b is equal to 2. We know what a is. A is 6. So we can say that 6 divided by b is equal to 2. So this tells us that 6 divided by 2 is equal to b, which is equal to 3. In our equation, we're going to need b squared, so let's go ahead and write that down. B squared is equal to 9. Now we can go ahead and write down our equation. It's going to be y squared divided by a squared, which we found to be 36, minus x squared divided by b squared, which we just found to be 9, is equal to 1. Let's do one last example, and I think it is definitely the most challenging one. Here's example 4. We again want to find the equation for the hyperbola that has given vertices and then passes through a point. That's the part that's new. Our vertices are given as plus or minus 2, 0, and our hyperbola passes through the point 3, square root of 30. Let's write down the equation for our hyperbola first. Notice that the x component of the vertices changes, so that means our hyperbola can be written down as x squared divided by a squared minus y squared divided by b squared is equal to 1. Our vertices also tell us that a is equal to 2, so a squared is equal to 4. Now what we need to do is find b squared. To do that, we are going to use that we were told that the parabola passes through the point 3, root 30. So we can set x equal to 3, and then y equal to root 30, and we know that a is equal to 2. So we're going to plug these three values into our equation and find b squared. Let's go ahead and let's do that. X squared is going to be 3 squared. A squared is 2 squared minus y squared, which is the square root of 30 squared, all divided by b squared, that's our unknown, is equal to 1. So this is 9 divided by 4 minus 30 divided by b squared is equal to 1. Let's go over here to the right and solve this. I'm going to bring the 1 to the left and the 30 over b squared to the right. So this gives us 9 over 4 minus 1 is equal to 30 over b squared. We can think of our 1 as 4 divided by 4. So we have 9 minus 4, which is 5, divided by 4 is 30 over b squared. If we cross multiply these, set it equal to this, we get 5b squared is equal to 120. We divide by 5 and we get that b squared is equal to 24. And now we can go ahead and write down our equation. I'm going to go up here to the top to write it down because we've run out of space. Our equation is going to be x squared divided by a squared, which we found to be 4, minus y squared divided by b squared, which we just got to be 24, is equal to 1. And that's it. You now know how to identify the vertices, foci, asymptotes, and transverse axis of a hyperbola, and how to write the equation that describes it. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.